Bismillahirrahmanirrahim. Assalamu alaikum. My name is Itisham Sajjad and my group member's name is Avishwa Sajjad. I am from the Department of BS Biotechnology. I'm a roll number is 005. Today I am here to present a presentation on second order integrated law, and my fellow group member had already presented how the derivation of the second order uh, equation has been derived from integrated laws. Now I will show you that the two equations that we have derived are these, and by using the equation B we get some values, and if we plot these values in a graph we can see that the concentration of the reactant decreases rapidly at first but then changes more slowly than it would for a first order reaction with the same initial rate. Here is a graph which shows that the concentration by time. This showing down of the second order reaction means the slowing down of the second order reaction has important environmental consequences. Because many pollutants degraded by second order reaction, they remain at low concentration in the environment for a long time. Equation can be written in the form of a linear equation, as it is shown in down below. Y-intercept slope x. So we compare the first order and the second order by the graphs. We can see that the inverse of the concentration by time shows that they produce a straight line slope, but in the ascending order. Whereas in the first order, it is in the descending order, but it's not inverse of concentration. So to determine whether a reaction is second order in a reactant, we plot the inverse of concentration against the time and see whether we get a straight line. If we if the straight line if we get the straight line, then the reaction is second order and the slope of the line is equal to k. Whereas in the first order, the straight line is equal to minus k, not k. So as we have seen that the first and second order rate laws, each integrate law rate laws can be rearranged into an equation that when plotted, gives a straight line. The rate constant can then be obtained from the slope of the plot. Here is a summary of the rate laws or the order of reaction of zero order, first order, and second order. In all these, we get to know that all of the orders has been derived from the integrated rate laws, and if apply and if they produce, and we get a straight line, uh, whether it's in the ascending or descending order with different signs. Only the sign changes in the second order with a positive. A second order reaction has a long tail of low concentration at long reaction time. The half-life of a second order reaction is inversely proportional to the concentration of the reactant. So that's all from my side. Thank you. Allah Hafiz.